So these will be the solutions for the day 8 problems in your packet if you struggled. So the first one here is 32. It says the least common multiple of a number n. That's kind of confusing right off the bat. A number n, so there's a number hiding underneath n. So n is just a variable. So when you see an n or an x, that means there's a number hiding under there, and it's your job to figure out what it is. So the least, what are we looking for? Read the question. It says the least common multiple of a number that we do not know, so we don't know what this number is, and 6. So this number, n and 6, the least common multiple is 42. Well, let's do what we already do know. We know how to find the multiples of 6 to get to 42. So we can say 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 2 is 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36, 6 times 7 is 42. So this, we took 6 times 7 to get to 42. So we can work backwards from that. So 42 is a multiple, and it's multiplied. How do we get 42? We said 6 times 7 is 42. So we need to find a number that also has 42 as the smallest multiple. Well, if I did 6 times 7, maybe, just maybe we should try to say, okay, instead of n, I'm going to erase this. Let's try 7, since we see 6 times 7 is 42. So up here, let's do the factors, the multiples of 7. 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21. 7 times 4 is 28, 7 times 5 is 35, and 7 times 6 is 42. So we've got a match. And in class I say when you have a match, we'll see if it's the smallest match, the least common multiple. All right, I don't see any other matches here. So 42, so works out, it is the least common multiple. So what's the answer? Well, the answer is 7. The 7 would be hiding under n. Remember, they started off with what? The least common multiple of a number n. In this case, we know n can be 7. This problem could be also written as the least common multiple of 7 and 6 is 42. Is that true or false? Yes, that would be absolutely true, right? So the answer is 7. 33, the greatest common factor. So now we're doing factors. The greatest common factor of a number n. So we don't know what n is. So n is kind of like the question mark. N means there's a number hiding under it. So n and the number 6 is 3. Well, first let's do this. This is going to be a number. I'm going to put it on that line. But let's first find the factors of 6. 1 and 6, 2 and 3. All right, so up here we need to find a number. In this case we're calling it n. We don't know what it is. Where the greatest common factor is 3. So we need a number that will have the same common factor as 3. So I like to think by writing out numbers. Well, 1 wouldn't work because the factors of 1 are 1. Would 2 work? Well, the factors of 2 are 1 and 2. Would 3 work? 1 and 3. 3. So maybe 3 would work. So let's put 3 here. Let's pretend 3 is hiding underneath here, n. The factors of 3 are 1 and 3. Would that meet the criteria for the problem? What's the greatest common factor of some number and 6 is 3? Well, 3 would work because they share a 1 and they share a 3. So I'm going to circle. This is definitely a winner, but this says what are all of the possible solutions? So 3 would work. Let's do 4. Would 4 work? 1, 2, 4, no, 5. See, I just worked through 6. We can't use 6, we already have it. 7, no, 1 and 7. 8, 1, 2, 4, 8. No, that doesn't have any 3s in it. How about 9? 1, 3, and 9. So up here we could say, well, let's try another number. 9. 1, 3, and 9 are the factors. So if this one's a 3, this is the factor of 3, and it would share a greatest common factor also up here with 9, which would also be 3. So 9 is also correct for this problem. So 3 and 9 would be all of the possible number values for n, which, remember, n it's just a math way of saying there's a number hiding underneath the n, and we figured it out. It could be 3 or 9. Make up a word problem that you can solve by finding common factors. Oh boy, common factors. All right, I'm thinking back to the bag problem in class. I'm going to make up a problem. I'm going to pause the video and write it out. All right, so here's my problem. I wrote, Mr. K wants to share 12 biscuits and 8 hot and spicy wings. What is the greatest number of people he could share with? So a way to attack this problem is I put some numbers in there. I've got 12 biscuits to share and 8 hot and spicy wings. So 12 and 8. So if I have those numbers, 12 and 8, I'm going to move this up. 12 and 8. What are the factors of 12? So if we go like this, we say 1, 2, 3, 4, 6, and 12. What are the factors of 8? 1, 2, 4, and 8. All right, so what's the greatest number of people he could share with where they all get equal? I'm assuming you understood that. So we could do, we'll make some plates here. We could do one, this is one plate, and I would have 12 biscuits and 8 wings if we had this one plate. So that's not sharing with a lot of people. What if we had 2 plates? 2 plates, there's 1 and 2. So if we had 2 plates, we could do, let's see, 6 biscuits and 2 plates, we'd have 4 wings. So 6 and 4. I'm trying to use color so you can see. Well, that's only 2 people, right? That's not that many people. There's 1. Here's another one. That would be 2. I'm going to draw all these. How about 3? Well, we can't use 3 plates because 3 isn't even a factor of 8. So we have to go to 4. So 4 is the greatest common factor. So if we had 4 plates, 1, 2, 3, and I have to put 1 down here. So there's my 4 plates. That means we would have, each person would get, well, 4 times 3 biscuits. So each person would get 4 biscuits. And what about the spicy wings? Well, each person would get, I should have used red for the spicy, each person would get 2 wings. So there's 1 person, 2, 3, 4. 4 people is the greatest, would be the greatest number of people that he could share with. Not including himself. Not including himself. And how did I get it? I drew a picture. Draw pictures. Draw pictures.